Lesson 27, the binomial probability distribution. Example 4. If a non-colorblind father with genotype working X and Y and a carrier mother with genotype working X mutated X were to have 3 children, find the probability that they would have at most 1 colorblind child. Well, here we seek the probability. And the probability is focusing on having a certain number of colorblind children. And each time a child is born, it could be either colorblind or not colorblind. Thus, this follows a binomial random process, since a child is born either colorblind or not colorblind. That is, 2 possible outcomes. Now, in order to use the binomial probability distribution formula to calculate probabilities, we need to know the value of the 3 variables, the n, the p, and the x. N represents the total number of attempts in the binomial random process. In this problem, it states that if this couple were to have 3 children, so the total number of children will be 3, thus n equals 3. Next, p. P is the probability that this couple would have a colorblind child every time they were to have a child. Now, the information given is it's a non-colorblind father and a carrier mother. And each time they were to have a child, there are 4 possible outcomes that can occur. And of these 4 possible outcomes, only one of them results in a colorblind child. So assuming that each of these outcomes are equally likely, P, the probability this couple would have a colorblind child, is 1 chance out of 4, or 0.25 decimal. Now for the random variable x, it takes on the values according to the question that we're trying to answer. And here the question asks, what's the probability that this couple would have at most 1 colorblind child? So the value of the random variable x that corresponds to having at most 1 colorblind child would equal at most 1, which is the highest it could be as 1, or anything lower. So at most translates into less than or equal to. So here, x would have to be less than or equal to 1. And in the binomial probability distribution, x is a frequency, or a count, and it could take on any values from as low as 0 up to as high as n, in this case 3. So the values of x that are less than or equal to 1 would be x equals 0 or 1. So these are the values that we want included in our probability answer. Now, to find the probability using the TI-84 calculator, the binom CDF command would be the one to use here, because the binom CDF, C for cumulative, finds probabilities of less than or equal to. So the probability they have at most 1 colorblind child would be the probability that x is less than or equal to 1. So using the binom CDF command to find the probability of being less than or equal to 1, we'd have to input values of n equals 3, comma, and p equals the 0.25, comma, and then x equals 1. So we could do this on the TI-84 calculator by pressing the second DISTR button to get all the probability distribution formulas that are programmed into the TI-84 calculator, and then arrowing down till we find the binom CDF command. Press enter to select, and then type in the values of the variables, 3, comma, 0.25, comma, 1, close parenthesis, enter. And here we have the probability. It rounds off to 3 places after the decimal to 0.844. So there's our result. The probability is 0.844 decimal. So, if a non-colorblind father and a carrier mother were to have 3 children, the probability that they would have at most 1 colorblind child is 84.4%.